All right, let's talk about code. If you've ever built anything, you know the real challenge isn't just getting it to work the first time. It's writing code that you're not terrified to touch 6 months down the road. Today, we're going to crack open two key principles that help you write cleaner, stronger code that actually lasts. You know that feeling, right? That little jolt of panic when someone asks for a small change. You start sweating because you know that pulling on that one little thread might unravel the entire sweater. That feeling, that's the sign of fragile code. So how do you get over that fear? Well, you build on a solid foundation. And in software, that foundation is a set of guidelines called SOLID. Honestly, they're like a developer's secret weapon for building software that's easy to manage and a heck of a lot more robust. Now, don't get hung up on the acronym or think of these as some strict, rigid rules. It's way more useful to think of SOLID as a toolkit. It stands for 5 really powerful ideas that help you build software that's, well, just a pleasure to work with. Not just for you, but for the next person who has to look at your code too. Okay, let's open up that toolkit and pull out the very first tool. We're starting with the S in SOLID, which stands for the single responsibility principle. And the best way to get it is to walk through a super common example that probably looks a little too familiar. So, say hello to our bird class. At first glance, it looks totally fine, right? It's got stuff like weight and color, and it can do bird-like things. You know, fly and eat. Seems simple enough. But, there's a problem lurking right under the surface. And that problem brings us to this core idea, laser focus. The single responsibility principle says that a class should have one and only one reason to change. Basically, it should do one thing, and it should do that one thing really, really well. This visual just nails the concept. I mean, look at the robot on the left. It's trying to be a chef, a painter, a gardener. It's a total mess, right? It's inefficient, and if one part breaks, the whole thing goes down. But on the right, you've got a team of specialists. Each one is focused, efficient, and does its job perfectly. That's what we want our code to look like. Okay, so back to our bird class. Here's where it all starts to fall apart. Not all birds fly the same way, do they? An eagle soars high, a parrot kind of flits around, and a penguin, well, a penguin does more of a swim flap thing. Suddenly, our one little fly method has way too many jobs. And when you try to cram all of that logic into one place, you get this awful domino effect of problems. The code becomes a total nightmare to read, it's impossible to test properly, and forget about reusing any of it. But the biggest problem is that it now has a bunch of different reasons to change. Any tweak to how eagles fly, or adding a new bird entirely, means you have to mess with the same block of code. So, how can you spot this in your own work? Well, keep an eye out for these big red flags. You see a method with a crazy maze of if-else statements? That's a sign. Or those monster methods that you have to scroll for days to read. That's another. And the worst offender of all, the God class, a class that knows everything and does everything. This whole mess actually leads us perfectly into our next principle, which is the O in SOLID, which isn't the open principle. And this one is all about building our code so that it's ready for the future, so it can evolve without completely breaking. Let's ask the million-dollar question. What happens when your boss comes over and says, hey, we need to add a sparrow to the app? With the way things are now, you've got to go digging back into that huge, messy fly method and add yet another if statement. You're changing code that already works, which, as we all know, is always a scary proposition. This is where the open/closed principle comes to the rescue. It's a really elegant idea. It says our code should be open for extension, meaning we can add new features, but closed for modification. In other words, we shouldn't have to change existing already tested code just to add something new. And this image explains it perfectly. Think about it. You wouldn't shut down a whole factory and take a robot apart just to give it a new drill bit, right? No way. You design it with a port where you can just plug in new attachments. That's extension, not modification. And that's exactly what we want to do with our code. So, how do we actually do this in code? The magic word here is abstraction. What we're going to do is create a general blueprint, a kind of template for what it means to be a bird, without getting stuck on the tiny details of every single species. All right, so let's see what our bird class looks like when we reimagine it using both of these principles. It's a total transformation. I mean, the difference is just night and day. On the left, you've got our old, tangled God class. It's fragile, it's a pain to change. But on the right, you have this beautiful, clean, organized structure. We've got a parent bird class, that's our blueprint, and then specific child classes for each type of bird, like eagle and penguin. So this new abstract bird class, it's basically a contract. It says, look, all birds have a weight and a color. But for the fly method, it just lays down the law. Hey, if you want to be a bird in this system, you must provide your own instructions for how you fly. It doesn't do the flying itself, it forces the specific birds to handle that responsibility. And just look how clean this becomes. Now, making an eagle class is super simple. It just inherits from the bird blueprint, and its only job, its single responsibility, is to define how an eagle flies. That's it. And if we need to add that sparrow, we just create a brand new sparrow class. We never ever have to touch the eagle or penguin code. It's safe. It's closed for modification. So we did all this work. We refactored our code. What's the big payoff? What do we actually get out of this in the real world? Look, when you go on this journey from code chaos to code clarity, the benefits are huge. Your code is way easier to maintain. Testing becomes a piece of cake because each class has a very narrow, clear job. And you get this incredible flexibility. You can add new features with confidence, not with that old feeling of fear. And that's our look at the first two solid principles. There's such a powerful way to think about how you structure your code for the long term. So I'll leave you with a question to take back to your own work. What's one class in your project that's doing way too many jobs? Find that God class, because that's the perfect place to start making things better.